is a new member in the IIPC. My presentation today is about ArcLink. It's an additional API support for the Wayback Machine. The beginning of this work started during my internship at Internet Archive, and I'd like to take this chance to thank Chris and Aaron and the whole Internet Archive team to give me this chance. What is ArcLink? ArcLink is a complete system for the extraction and preservation, and the access for the temporal web graph. If you'd like to take this definition of what is the web graph generally is the link structure between the web. So, for example, if we have this web page Rx that has two outlinks or two href for two web pages. This is what we call the link structure to include the outlink and in-link between the web pages. Even this is the structure, and we call it web graph, but it's not static because it changes through the time. So maybe at another point of time, this link between Rx to Rz had disappeared. So we define web graph as this kind of complete link structure that contains the in-link and outlink for between the web pages with in the whole timestamp all the observations that we have in our system. What are the motivations behind this work? The motivation started from this wonderful report that started, I think it has been published in 2006, and include all the use cases for accessing the Internet Archive or the web archives in general. In this proposal, they mentioned some project, I think it's called ArcSys, and in the use case 4.3, they mentioned directly that we need an ArcSys to display the incoming links or the link structure between the web page, including in links and out links. And it's not secret that we borrow our name from this system, ArcLink. Another motivation came from another ongoing research in our group to analyze the web archive, the Wayback Machine access logs. And we found that there is a significant number of robots access to the access for the Wayback Machine. It is because it's maybe 10 to 1 for the number of sessions because usually the robot use very small time for the session. And for the HV access, almost half. And for the transparency, they usually take 80% of the transfer for the information or the transfer for the data. And here's the question: why robots access the Wayback Machine? Why is it needless? And here we think about we have some solved questions and unsolved questions. For the solved questions, for example, if I ask you, what are the titles for example, Vancouver 2010 through the time. This question could be answered by you will get the time map and extract do page scrapping and extract the title header. You may solve the question by this wonderful list of all the titles through the time. Even a solved question, but it's so hard because it extends the operation for all the Wayback Machine or the infrastructure system. Even the solved question is hard. We have unsolved question based on the current infrastructure of the Wayback Machine. For example, if I ask you what are the anchor tickets, what are the incoming links for this URI, the current infrastructure of the Wayback Machine couldn't help us in this question. That's why we believe that the researchers are using the page scrapping to build their collection and to help them to start their research. And here we give two examples from publications that just came in 2012. Mr. Walker built a crawler for the Internet Archive to extract the information, to build the evolution, to examine the evolution of the hyperlinks between the stuff. So he built crawler for the Wayback Machine. Also, Mr. Kruger in his publication discussed the challenges of crawling the web archives and the difference between crawling the web archive and crawling the live web. So we believe that there is a need from the researcher to reach the metadata and reach the information from the web archives to help them to do their research. Now maybe this question came to your mind that we are developing the web file maybe for 3 years right now to help them for the metadata. What's the difference between what we are providing and the web file? Here I tried to provide summary between the difference between both of them. Mainly the first thing is that the operation itself. For example here, for the web file mainly is a fetching process of the work file. You have a bunch of work files, you run through the script, and you create web file. And web file for each one of these work file. On the other hand, our link starts with list of URI or list of methods. I need to create the link structure between this list of URIs. And we start from this step and going through the rest of the step. The second difference is that the internal usage of the web file. Mainly, web file has been developed for the internal use, even by the institution or other partner for doing their research. On the other side, we believe in ArtLink, we need this to do for the public users and other researchers. That's why we are emphasizing on the how to access this information. The third thing is integration. And there is no way to integrate what file has been created in the archive and what files are created in the Bridge library. There is no way to integrate this stuff unless you copy the file to the other locations. But for the ArtLink, the aggregation between the different graphs was a key point in our implementation. The fourth step is the incremental update. What file doesn't need incremental update because you create the web file from the web file and that's it. There is no kind of incremental update for the created web file. On the other hand, ArtLink depends on the incremental update. So if you have one collection, you can include it to your system, another collection for 2010, 2011, 2012, and you can include it incrementally to your system. Finally, for the access, mainly the web file is accessed on the batch access, maybe Pig or Java or something like that, to work on the whole web file. On the other side, ArtLink based on the URI access, so you can access the data based on URI lookup for a web service that covered all the access interface or the API interface for the ArtLink. We implemented our implementation based on the Olympics collection 2010 with roughly more than 23 million mementos, and the size is around 700 gigabytes. Okay, let's move to more technical details. We divided our system into 4 stages for filtering, extraction, reservation, and access. We depend on some kind of modularity between the system and the different steps to give the implementation of the institution the freedom and flexibility to change the different modules based on the infrastructure. Let's start with filtering. The whole idea about the filtering is how to exclude the web pages that will not contribute to the web graph. Mainly we focus on for the general creation of the web graph, focus on the outlinks, the web pages and URIs that has outlinks to other web pages. In the live web, you can't exclude this stuff until you access the web page. But for the web archiving, you already have some kind of information about what you have in your collection. For example, the CDX file could be used as a crawler log. You already know what is this memento about, or what is this URI about. And from this, you can exclude, for example, exclude the images, exclude style sheet videos, 200 GB stethoscope, the topic mementos. All this stuff could be excluded from the processing, so you can save some time for the extraction level instead of accessing this URI, accessing this web page and discover that this URI doesn't count it to us. For the technology, we use Big Latin and Big Latin spread, and the result was significant. We reduced the CDX file for 25% of the original for the original size. The next step is the extraction. For the extraction, we use Hadoop, and if we think about the Hadoop and the extraction of web pages and for different incremental updates, the first idea here came to our mind is how to generate IDs for these web pages that may appear on different machines or may appear on different batch process. And here is the step number one for the URL generation is the idea of canonization. We canonize all the URIs that we have for using SART format and using this format by hashing technique. So each URI, the hashing or the ID for the URI is generated by the URI itself. So wherever, which machine, which run it appears, it will map to the same ID. So it helps us for the distribution and the scalability of the work. The second step, what are the data sources that you have in your collection? So in this implementation, we compare between two of them, the WAR file and the Wayback Machine. If you have access or if you have information about which URI has in this URI, the location of this URI and the WAR file, which is already in the CDX file, you can use this information. And the result here was interesting. For accessing using the WAR file, it just takes 60% of the time for accessing through the Wayback Machine. And in additional to the saving in the time, think about that you save your computational power of accessing the Java, the web application, and access the Wayback Machine will access the CDX file and hold this process. We save this process. Again, our initial, we depend on the CDX file, which has all this information. So we are focusing on using this information to save our computation power. For the storage, we are using similar database to save the extracted web graph for the further access. And generally speaking, we found that we have linear performance for the insertion and the update based on our experience. Okay, for the access, which is the interesting thing for the user in this case, we depend on URI log. If we see here for the first line, you will see how you can access this the system. So we have here in the first step, you pass the URI as a parameter, something similar to what the Wayback Machine are doing. The response, we provide the response as XML RDF, and the reason is that it's machine readable. You can annotate the stuff easily, and we believe it's easy for the aggregation with other RDF statements. If we need to go through the stuff, the first two tools is just the declaration for the XML and RDF, and here is the starting of a statement of the RDF. So here is the subject. So whatever will come after that, it's related to the Vancouver2010.com. So for this, we have two predicates. Number one is the has out links, and under the has out links, you will find that you can read it like that. For the Vancouver.com has out links to this URI with this. Let's think about the host. Here is on this side we have detailed for our empirical study, but let's think about if we need to apply this information on the Wayback Machine based on the information that published on last January by having 240 billion mementos with 5 petabytes. I change it right now. For the filtering, I think it's not the main problem. It may take around 60 hours based on our calculation to filter the CDX, the whole CDX collection. The extraction, maybe the bottleneck, it may take less than 6 months to extract the whole link structure. We believe that's okay, but 5 petabytes, a lot of data. Okay. The storage and the current implementation has almost 10% of the collection as a storage, so we may need 500 terabytes for the storage of the ARC link. We believe this is the initial implementation without no configuration for the compression or something related to database. So we can go more saving for the space. We believe ArcLink is working fine with a small and medium collection. For the big and the huge collection, it needs some modification to fit this kind of the big collection. And the interesting thing here is the idea of the iteration. So you can start with every year, for example, or different iterations through the time instead of extract from the whole collection. Let's relate to the Wayback Machine, how we can use this as an extension for the Wayback Machine. From the technical perspective, both of them implemented as a Java web application. Both of them are URI lookup. So from the development perspective, there is no problem for the integration between both of them. The question is from the user perspective. Now we are going to add more access points and more interfaces for the user. Right now we have HTML for the Wayback Machine, Memento, time map, and additional to the RDF for the ArcLink. So in the future, and we believe in the future, we can add more access points. So the question now, how to integrate between these interfaces? We are looking for answer to this solution during this meeting. From your experience and your interaction with the user, how we can provide the integration between these different access points. Should we make it different? Should we include it in one interface? We are looking for this answer from your side. Okay, let's think about two applications that we have, and let's solve our unsolved questions. Now, for the first question, what are the anchor texts for this URI through the time? By having this XML, it's so easy to extract this information from your XML and get this information about a URI through the time. And so it's so easy to extract this information. And the interesting thing here is that even if this URI is not in your collection, you can still collect information about it from the other output. The second application is that we just think about it, the temporal page rank. And this is important for the archive to provide fault text search and having this information, how to rank the result. Because the rank is changes through the time. We try to improve this stuff by dividing the collection of the Olympics into per month and take each slice and to try to rank this month. So this is for November. For December, we don't have enough observation to rank the URI through December, January, and so on, and the whole collection. We have different rankings through the time, and if you see here, most of the information is the beginning. The highest rank in the beginning focused on the Vancouver and the website itself. And at the end, most of the highest ranking is for the newspapers because they may speak about what happened in the Olympics, what was the result, and this stuff. So we believe there is a difference during the time. We didn't address this problem yet and how to solve it, but we provide the temporal web graph that will help the researcher after that to address this problem and solve this problem from their side. So finally, if you need to try the code, we provide on the Google code. We still have some problem to put it on the public website and the stable website to try it out and give us your feedback. Generally speaking, ArcLink will provide some type of extension for the current functionality of the Wayback Machine that will help the researcher to get the information that they need. This from their side, from your side as web archive, it will save your computation. You may spend some time for this kind of extraction and preservation and this stuff, but on the other side, it will save your machines and infrastructure for the access for the real users who need the current or best web pages. Thank you, and time for questions.